Hello and good evening, everyone. Today we've come for the session Introduction to Compiler Construction, Ballerina Language as a Case Study. Quite a mouthful. But for the event today, we have Mr. Manuranga Pereira, who's Senior Tech Lead or Senior Technical Lead at WSO2, which I think it speaks for itself. And obviously, for that, I think without further ado, I think we'll move on to the session so you guys can learn about this language and what it does. So, Mr. Manuranga Pereira, the stage is yours.
All right, hello. Good evening, everyone. Welcome to the stream. Uh, so, uh, let me start with a little bit of introduction about myself. I'm Manu Ranga Pereira. Everyone calls me Manu, and I've been with WSO2 for a long time now. But I joined the Ballerina project maybe around 4 years ago. So it started a little bit. And then I first joined this project to work on the IDE side of things. I'll talk about it a little bit later. And then from there, I've been working on. I've worked on the Ballerina backend, the Ballerina runtime part, and then right now I'm working on self-hosting part of the language. So I'll talk all about all of that. So let's get started with our slides. All right. So yeah, so the outline of the talk will be. I'll first talk about a little bit about the history of the Ballerina programming language, why we started this language, what was the goals, and how we progressed along the way. And then I'll also talk about a little bit about how the language looks, what are the features, why these features are important, and how they serve the purpose of being a network programming language or cloud programming language um, that's that makes it easy to integrate services, right? And then after that, the second half of the talk, I'm going to talk about the engineering experience. So that mainly about experience of Ballerina team in general, as well as my experience, because this has been and this continues to be an incredible journey. We are developing a serious piece of technology, and that has been a really great experience, and we have learned so much. Sometimes the hard way, sometimes uh, we have to rewrite things, we have to discover things, because this has been somewhat new for us, somewhat, there's some experience as well. Okay, so first of all, I think whenever we talk about Ballerina language from WSO2's perspective, because as WSO2 company, one of the first things people ask about is why programming language from a middleware company, because that's the traditional view of the WSO2 company. But when I step back and take a look at what we've been doing at WSO2, I think we have always had this notion of certain low code or no code approach. So, but the wording has been different. So, uh, it used to it, this. So the word no code or low code has been kind of a new invention, but the idea, the paradigm has been always there. So WSO2 has been contributing heavily to Apache Synapse project. In fact, that's one of the core early things WSO2 picked up. So this is XML based language that allows you to write mediation, or so the mediation is the old word, so you can think of it as service interactions, right? So in a way, that is a language, and then we've been, not in a way, it is a language, but the vehicle was XML, right? So we WSO2 has been always working on these low code environments, and uh, more to that, we have been working for a long time for a graphical with a graphical editor. It used to be uh, both web in web and uh, uh, standalone base, we had a graphical editor for a long time, but again, that has been to generate those XMLs, right? So it's not like this is a completely new space for us. We have been working with languages and we have been working with IDEs for a long time. And also we had a product called, not product, a framework that's mainly for internal use. We maintain something called Jaggery, and that is similar to what Node.js. I think everyone knows what Node.js is, and it surprisingly, this is not a clone of Node.js. We came up with at least, I think, maybe the same time or slightly prior, or around the same era that Node.js became popular. So it's more of a convergent thinking, I guess. So we had this framework that's written in Java, but it can run JavaScript, and then it can produce HTML pages. So, but over time, I think the world has moved on from server-side rendering. Maybe it'll come back with there's new frameworks popping up like Next.js. So whatever was all these new, right? So these things come and go. So maybe we'll see a resurgence of backward rendering again. But what I'm trying to say here is we have some experience maintaining runtimes as well. So we had mixed bag of experience, but this is the Ballerina is the first time we are kind of stepping into general purpose procedural language world. So that has been new experience. Um, so let's go to the next slide. So I'm going to, so this is a kind of a brief overview of timeline and what happened. So so around 2016, I think maybe mid 2016 um, to late 2016, we were looking for a replacement for this Synapse language, mainly because XML is a good language to represent data, but it's not a very good language to represent logic, or especially uh, programming logic, right? So it's becoming cumbersome, and then people do not like to program in XML, and for the, I mean, even JSON or whatever, JSON is not also a good format for representing logic. It's a good format for representing data, but not logic. So we wanted to replace this XML based language with something that's easier to write, more convenient, and captures the logic much better. And our CEO and founder Sanjeeva, you might know about him. So he has been inspired by sequence diagrams and how useful they are when we are explaining something to our clients. So since our clients are usually working with multiple services, and then there's complex interactions with them, so whenever we sit down with clients, it's much easier to explain a complex scenario using sequence diagrams. So Sanjay wanted to bring that sequence diagram experience into uh, a programming language, something editable in an editable format. And what's important is, from the very beginning, we had this idea that sequence diagram, while it is a graphical thing, it has to have a textual representation always. So from the very beginning, uh, we had the base that we'll always have a text representation as well as a graphical representation, and they are dual of each other. So not like one, this is completely a UI drag drop thing, because UI drag drop things are there, but they're not always successful, because they're very good at getting started, and then you want to do some little bit of edge case, you need a little bit more control, then you have a fallback for those places. So we had this notion of text and graphics at the same time, concept from the very beginning. So that was late 2006, and then that's where the project started, and it slowly kind of evolved into we started with a kind of a more DSL like language. That means it used to be you can't do too many arbitrary things, but we soon evolved from that to being able to do more general purpose logic, because that otherwise we felt like we always have to fall back into JavaScript or some kind of scripting language to do advanced things. So we wanted the Ballerina language to be complete, and you will be able to do the integrations very easily, but you can also do the complex logics in places where you need it. And I was not strongly involved in maybe 2017, uh, but I was back working on the project in I think mid 2018 on the IDE side. So what happened in the meantime is we did a release. The team did a release in 2017, and that is AST interpreter based language. I'll talk about how AST interpreters work in the later section where I talk about the actual architecture. And then we and at the time of development, even at the time of development, that felt like it's not the final solution, but it's kind of a stepping stone. So again, late 2017, team came up with another solution, which is this BVM based solution, and that solution served us for a long time. It was a good much improved, much better improvement over the AST interpreted version we had, and that lived up to until maybe late 2018. So that's again the part I worked on directly. So uh, we worked on at the time we started working on another backend. So that's an interesting offshoot how that happens. So we we had this BVM backend, which I'm going to talk about in the future, which is working on a reasonable fast level, reasonable performance, and then we were working on some native backend, but that native backend project didn't pan out that well. But as a result, we got the JVM backend. JVM backend is where we, from the Ballerina code, we produce Java executables, basically Java files. And then this is what we are currently work, working with. So we just did a release in few days ago, I mean a month ago, so a month or so ago, which is the Swan Lake release. And this is a very good time to get into Ballerina programming language. So if you want to explore, because we just did this GA release, and then we are going to maintain this GA release for a long time. We are going to continuously improve and update it. So this is a good time to write some programs and uh, get into the whole Ballerina sphere of things, right? Up until Swan Lake GA, we were changing a little bit, not a whole lot, but little bit enough for you to where you have to change your code with us. But with Swan Lake, we are very stable, so we will maintain a reasonable amount of backward compatibility for a long time. So it's very good if you want to get into Ballerina, which I strongly recommend. And what's going to happen for the future of this Ballerina project is we are going to, again, as I said, we're going to do a time-based updates. That means every certain amount of time we are going to release an update. So it's more like rather than having updates whenever we do a feature, we do a release for a given amount of time. So you'll always get continuous updates, and each update we are going to do a little bit more improvements. And that's for the Swan Lake crack. And then WSO2 Choreo platform, which is currently in beta, or check that out as well, please. So this is the uh, coding platform we developed on Ballerina. So it's not Ballerina per se, because we are planning to Ballerina only per se, because we are planning to put more languages into this platform. But right now, the core thing it supports is Ballerina. So you can try to you can try some writing some programs So it's a platform where you can write a program and then take it into production just by clicking some buttons, right? So, and we are going to go GA with it soon. So it's right now in BA, so anyone can try. So, and while all of this is going on, our long-term project is we are planning to also do a native backend, which is the part I'm working on right now. I'm working on, which is the team I'm working on right now. So I'll talk about it more about it in coming slides. Right. So okay. So let's now this. Now let me introduce you to the Ballerina language a little bit. Um, so so the language. So I'm going to introduce only kind of couple of features. So you that will hopefully interest you to go and try it out, and it's a very easy language to pick up, but there's a lot of depth, there's a lot of things you can do with it. But it's if you have worked with any kind of C-like languages, Java, JavaScript, TypeScript, C sharp, anything, so yeah, I think it'll be fairly easy to pick up. But there's certain differences, certain things we have made it so it's easier to work with network programming, right? So it's easier to write services with, it's easier to consume services with. So those are things I'm going to talk about right now. So the first thing we have highlighted here is the data oriented nature. So you can see, like, at the first glance what these two lines are. I have a user object, I created the object, right? First thing you'll notice is this is much shorter than a lot of programming languages out there. Just to do this bit, it'll take uh, many lines, lot of boilerplate in a lot of languages. But it's more than that, because even just by these two lines, you have not only have an object that has ID and a string in it. You can compare it. You can serialize it very easily. So all of that is also built in. It's not like you're going to write a serializer, write a equals operator, equals method, or anything like that, right? So what gives this flexibility is the fact that this is pure data, right? So there's no methods in it. It's just a pure blob of the data, and language makes it very easy to work with data and then define data, put restrictions on data, all about data, right? So why this data orientedness? Why is this introduced to the language? Is because Ballerina is supposed to work well with network, uh, and then what you get over the network is data, right? So this is not going to be a good fit for a language. Let's say if you're writing computer game, that's not, you're not going to get data and then pass like output data. But for a network programming, its primary purpose is consume data and then output data, right? So data is at the key, and data is something that's serializable, that's copyable, that's clonable, that's comparable, uh, that's and the language has optimized, like language is optimized for it. And so uh, here I want to highlight a slight difference from what you might expect. It's not just data, because it does have what we call storage identity. That means you can take a reference to it and then store it. So it's not going to be completely inefficient when you like put it into another object and so on. So it's uh, data, or the goodness of data, plus the references that you need for efficient implementation of something. Right. So we saw data. So the next point is concurrency, right? So the concurrency in Ballerina is built in. There's no need to import another library or something. But I have put a sample here that is very you know innocent looking also, so very you wouldn't look at this and think, okay, that's an example of concurrent thing going on, because you would normally expect, if it's a concurrency example, you'd expect to see a thread, you would expect to see a thread waiting on a thread, joining on a thread, starting the thread, something like that, right? But what's going on here is in Ballerina we have made it you don't have to think about explicitly about concurrency for the default cases. So here you can see there's a, if you have programmed with languages like uh, JavaScript, for example, right? You would start by first passing in a callback. So the callback is how you get uh, concurrency in a way, right? Because system will call you back when it actually happens, so something can run in between, right? So I'm talking about concurrency, not exactly. So that might not happen parallelly in a separate process or separate thread, but still, I'm I'm talking about piece of code executing, and then something else happens, and then we return back to this code, right? So how that happens in a language like JavaScript, for example, is by passing a callback, right? And this is a very um, it's getting popular. Has been there in those kind of languages, but it's now getting more popular even in languages like Java, right? You see some frameworks where it uses callbacks, and then next step is it's cumbersome because the callbacks, you have to write the callback here within a kind of a function thing, which makes the kind of language, the code becomes a little bit more fragmented. You go into methods, and it's very hard to debug because if you put a breakpoint, or if you get an error inside the callback, you can't find out where it went wrong. So there's a whole lot of problems like that. So now people are using, I mean, the solution to that in many languages is put async, right? So there's a keyword called async. You put async in front, so the language will take care of like pausing at that point. You put the async keyword on the function, and then you put a kind of wait kind of thing in front of the code. So the language will take care of pausing there, and then you don't have to this messy nestedness. But Ballerina kind of goes a step forward, so where it doesn't have callback, right? It doesn't have a kind of a uh, it doesn't have this separation between what is the async function and what's not the async function. So in Ballerina, this get call actually does something in parallel, does something in background, for example, but until it returns, there's another strand. We call them strands. So that's basically another parallel, another concurrent unit of execution can happen in between. So you don't have to do anything. The language will is designed so that it is uh, it will have the concurrency implicitly. So it's like you don't have to, you know, uh, partition all your programs into what is async functions, what is not async functions. So that's great, right? So you got something without writing a single line of single character, right? That's the best thing. Best code is no code, right? And next and we do have all these other things, like you can start a strand, you can wait on multiple strands, all of that is there, but it is when you want to explicitly do those things, and sometimes you do, but it's great when uh, the default things works out of the box. Okay? So the next thing is the graphical nature. So this is what I mentioned earlier as well. So from the beginning of the language, the language has been designed to be graphical and syntax. So it's uh, uh, you have best of both worlds, rather than just getting restricted onto some drag drop thing, or fully textual. You have best of both worlds. You can write it in text, and then you can later use the graphical explanation to explain it to someone, or you went to a new project, you can look at the graphics and figure out, okay, this is the high level picture, and I need to dive into this bit. So there's a lot of improvements we are still, ongoing in this area. So we currently have graphics, and you can test those out in both in VS Code. So we have a VS Code plugin, and if you install the VS Code plugin, if you write the program and then you click on the diagrams button, you can see the diagram, and you can see the same diagram on our online platform. Uh, but we are working on making this diagram even bigger. Like right now, you can see a diagram for a particular part of the program, but end goal is to make the diagram for the whole bird's eye view of a big program, right? So that's where we want to be. Um, but even as it stands, it's really illuminating when you see this diagram. Okay, that's what's going on in this program, rather than just trying to read all the bits and pieces. Right. So, so okay. Now I started this feature list by talking about data types, and so the next part of that data uh, discussion is, it's not, the data plays very well with the type system. The type system is designed so that you can express things about data, and then you can work with data fluently, right? So this is what that this is highlighting. So let's take a quick look at the previous slide. Okay, we had a user object, and it had two properties, right? And now I just defined another object, which is this customer object. It has three things, right? So in a more object oriented language, you would expect, okay, to say customer extends user or something like that, right? So but Ballerina is a structurally typed language, um, and you don't have to explicitly say that, and the language figures it out by looking at the structure. So if customer can be represented in all the places where user can be used, then obviously you can put customer into a place where one expects a user, right? So this is the this is the flexibility of the structured typing system. So you don't have to explicitly define things. So this plays very well with the way the networks work, right? So you usually get an input, and input is something that's sort of defined. You know what you are going to get. Yeah, you know the exact, some amount of the fields, but there might be a case where they send some additional fields in the future that you didn't account for. So in those cases, and some fields might sometimes be a string, sometimes it's not a string, it's an int. So all of these kind of weird, not weird, like complex data schematic uh, things in the API world is very well captured by this type system. So that this type system helps you to be resilient against the services you consume, and then be very strict about the output you produce, right? So so the Ballerina programming language does have a concept of objects. You can put, we have classes where you can put, data with methods, but it's certainly not a language where you want to create huge hierarchies of things explicitly, right? So all of that gets created for you in an implicit way when you define the data. So all you have to do is clearly define what you consume, what your data types are, and everything falls from there. So to make it easy, we have predefined data types, like we have maps, we have a special data type called table, we have list, and all of those data types are built into the language. And using those things, you can clearly define your data, and then everything else kind of sort of intuitively work uh, well. So there's a lot of uh, complexity goes going into figuring out how this type system works, but from the user's perspective, it is kind of very intuitive. If you know how sets work in mathematics, kind of have a sense for it, uh, then this you don't have to explicitly learn how ballerina type system works. There is complexity when it comes to what we call inherent type, but it's a deep discussion I won't go into right now. But for the majority of cases, you don't have to know too much about ballerina type system to say, okay, the user and the customer has to be a user, right? That's kind of obvious, even if I didn't explain rule by rule what the ballerina type system is. And that's what's so nice about this system, right? As the user, you don't have to know much, but as the developer of the language, we have to work a little bit hard to figure out all these rules. Um, yeah, and next point is cloud native. So we are certainly planning this language. We have designed this language to work with networks, and the reality of modern world is the networks exist in public clouds, and sometimes public private clouds, and in a sort of dockerized environments, Kubernetes, and all sorts of virtualization and containerization. Right? Containerization is the basically norm right now. So we have designed things to cater to that world very naturally. So once you write a Ballerina program with a service, you just have to mention that this is going to be compiled for Kubernetes, and then we will generate Kubernetes artifacts for you. So things are very well integrated with that world, because this is the world we cater for. Um, right. Okay. So let's how about with time? Okay. Cool. I think taking a little bit more time than I expected, but that's okay. I think. All right. So this is just an example, just to give you a glimpse of okay what a program written in Ballerina will look like. And I think most of it you will kind of intuitively guess and figure out, like, okay, there's a public main, yeah, that everyone knows, and then there's a bunch of function calls. One function call is a little bit weird because it has an arrow in it, but that's again a function call, but it goes out of the world. I think that's very intuitive. um, and then this from where syntax is, if you're familiar with SQL, if you're familiar with uh, link in C# world, I think that's you get a reasonable idea what's going on, and it's a very clean bit of code that does a lot behind the scene, right? This small program does a data mapping, get data, and transform it, all of that in just a couple of lines. So that's the power of Ballerina, right? Okay, so I think that's pretty much the portion of the talk I'm going to talk about Ballerina, the language itself. um, so if you have any questions about the language itself, please post in chats, and I can answer them, as well as I'll talk about how to reach us. And please try the language, and I hope I intrigued your interest enough to about the language itself. Right? There are some many cool things about how we handle errors, uh, how the concurrency works, and uh, the the types we have, like table type. So all of that there's a lot of examples in ballerina.io, so you can explore them there. Right. So in the next bit, I'm going to talk a little bit about our experience developing this language. As I said, this is the first time we work on kind of a procedural language, even though we had various experience in the language arena. So I'm going to assume that you guys are not intimately familiar with compilers. So I'm going to, in this section, give a little rough idea how a compiler works and various choices we had to make along the way to make this compiler work, right? So compilers, it comes in various forms, but this general structure is, if you look at most compilers today, you look at somewhat similar structure, right? You have a parser, and then you have a analysis phase, and then usually there is a multiple intermediate languages, and then there's a code generator, right? So that's roughly what a lot of languages do. And we didn't start exactly with this structure, but we certainly have ended up there. And I think we deeply understand why we need this structure. So so the parser, talking about the parser is the bit of a programming. I mean, parser is the bit of compiler that gets the text in and then turn it into some kind of object structure, right? And that object structure is what we call the AST. So I'll talk about a little bit what are the options we had there and how we ended up with the current thing. And then once we get that object structure, call it AST, or various forms of trees. So there are other options there, but AST is the most common one, I guess. So the AST, then there's a lengthy process of analyzing and then desugaring that tree down, basically transformation at tree level, right? So we first there are the phases we do is basically like we recognize all the symbols in the tree, and then we because we want to see if the X is used here, it's the same X used there, and that kind of thing, like basically defining symbols. And then on those symbols we do type checking, and then we do certain kind of constant propagations, because in some languages the constants are basically an optimizations, but the way Ballerina language works, the constants are very important, so we have to handle constants up front. And then we have to uh, we break down complex trees into much simpler tree structures, right? So that's what desugaring does. So there are many forms of desugaring we are doing. We are desugaring down things like closures. That means a function where you write a function within another function that gets compiled down to a small, like just a normal function call, things like that, as well as general desugaring. For example, if programming languages have ternary operators, that is question mark and then colon, right? That's same as if condition. So if condition and a ternary operator can be represented as the same tree at the lower level. So we have to, because it's simpler to have one thing rather than multiple ways of doing the same thing. Even though we provide at the language level, at the lower levels we transform it down to kind of a uniform form. So that's what analysis and desugator is. So after that, we generate another language. So how modern compilers work is we get the input language, in our case it's Ballerina, and then we compile it to a different language. And then some systems where you have multiple levels of this, right? So I'll talk about our internal language a little bit in the coming slides. So think of it like a mini programming language. So rather than directly generating machine code, even machine code or whatever the lowest level of code is also kind of a language. So in a way, all compilers are getting one language and then compiling it to a different language. Sometimes that happens to be machine code, right? But in 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 these days, in modern compiler constructions, usually there are multiple languages. You get the big language, you compile it to a smaller language, and you get the smaller language, you compile it again to a even smaller or even lower level language, and that's how the compilation happens. So okay, so now I'm going to go through this list of what we did and how we came to these choices, right? The first choice we had to make, or kind of the choice that has been made for us, is what are we going to implement this language in. So since we were kind of experimenting with this, and we had a lot of Java developers, and Java was our primary language we did a lot of things in, even though we had some experience in JavaScript and TypeScript and Go and multiple languages like that. Our core language we were working on was Java. It was Java, so we were working on Java by de facto. So and it has served us well. So it's uh, the thing about picking a language when you are starting a new programming language is it's very tempting to write the compiler in the language itself. But when you start with the existing language, in our case Java, it's very easy to change things around. And then because and you have experience in it, and you have a lot of developers who are familiar with it, and it's much easier to work with the existing language. And so along the way we have this is what we are continuing with right now in our Swan Lake version. But obviously this is going to change in the future, but for a long time we are going to stick to Java as the main implementation language. So we did try to write it in uh, Ballerina itself in 2018. So this is one of the efforts I was involved in. And my team lead, or the Ballerina team lead, Samira. So we were trying to write uh, not the full language itself, but at least part of it in Ballerina. But unfortunately, we realized we kind of started a little bit too early. So the language is evolving fast. And then the other problem is if the language is slightly too slow, or the compile itself is slow, that means either produced code is slow or the compilation process is slow, there's a kind of a feedback effect, because we are using the language we are developing to write the language itself. So what happens is if there's a small, uh, if there's a velocity problem, if things are not going smoothly, then it kind of gets doubled, right? So that was not a very good time for us to pick it, but we tried it anyway, because it's one thing is it validates the language, right? It shows if there's a bug in the language, in the sense design bug, for example, like if the language is not suitable for writing complex things, you'll realize it right away, right? But other than that, there's a marketing value in saying that okay, we developed the language in itself. So because it's a certain, that's what I put made by brownie points, right? So it's cool to say that our language is written in itself, right? So basically that's what it is. But unfortunately that was a little bit too early, and things are not moving as fast as we wanted. So we kind of converted that whole code base from Ballerina to Java, so that it's not a smooth experience, but you live and learn. And then in the meantime, we kind of tried briefly to write some parts of the native version of Ballerina. So the native Ballerina means compiling Ballerina into machine code that way, uh, using C++. But again, there are not not something we want to live in long run, because we then need to become experts in C++, and it's hard to find C++ experts, and there are problems like that. So you have to be very careful when you're programming too much in C++. So it's not the direction we want to go. So again, in 2021, very recently, one of our, again, core uh, uh, language team uh, person, James Clark. So he started this Ballerina project, which I'm now a part of. So we are trying to write the Ballerina compiler fresh from Ballerina itself. and that's kind of a long running project. So it's going to take some time, but that's coming. So that in that project, not only we are writing Ballerina in Ballerina, we are producing machine code. So that's ongoing bit, right? So as with any language, so we are going to, we'll have to use multiple languages to do the runtime in. So we'll anyway going to have some Java there. We are anyway going to have some C there. Hope maybe we might have Rust there. So it's anyway going to be polyglot development, but this is our current set. We do core of our mainstream version in Java, and then hopefully one day in the future we can switch over to Ballerina fully. Right? And one thing we have realized the is that writing Ballerina and Ballerina, we already got a lot of corner cases. We understand the language much better. That feedback went back into Ballerina, improving the Ballerina language itself. And right now it's a very complex code base, thousands of lines, and it still works. And then that's a very good validation that this language can handle even the complex things, even though the language itself is not designed to write huge complex programs. Okay, so the next, another important thing uh, we have to pick when we are starting a programming language is the parser. Right? Parser is the very first bit that gets the text input and then turn it into some kind of object structure. So to rest of the programming language, with the rest of the compiler to work with, right? So we've been using Antler parser generator for a long time. So the two options we usually have is using a parser generator or writing it by yourself. The parser generator is a program that you give it an input. So it's another small language basically. So you write it in that language and then you compile it and you get a program that can read text and then convert it into some kind of object structure. So you using the parser generator, you tell the parser generator what kind of a language you want, and then parser generator will give you some executable code back, right? Uh, and other thing is you just write everything by hand, right? And there are few approaches when you write it by hand, and there's something called parser combinators, and then the most common one is recursive descent, which is what we have done lately. So the parser thing with parse generators are they are very easy to get started with, and they are very clean. So if you look at the not the generated code is a mess, but if you look at the grammar itself is clean, and then you can look at it, and you can, even if you look at this code snippet, you can understand, okay, the function signature means whatever comes out function that has a parenthesis, and then you have parameters, and then it's very easy to read and then easy to maintain and all of that, right? But the complexity is when there's a complex grammar, and then Ballerina has evolved into a complex grammar. It's not complex for the user to write, but it's certainly complex for us to develop all the cases, all the edge cases, all the tiny bits. So towards late 2000, early 2020s, we've been getting various bugs, various incorrect results, various trouble with this parser, generated parser. But it works well for us for a long time. So if you are starting a project, programming language project, parse generator is definitely a good thing to start with, but it becomes hard to maintain over the time, and especially if you have a lot of complex rules. And even at this point, I remember we were using something called modes, which is kind of a advanced feature of the Antler grammar. So we couldn't get it done using the plain old simple grammar rules. So we were using kind of advanced grammar rules, but we could get it done, but there are edge cases. And especially what went wrong is when you have errors. So the thing is, users don't type um, everything perfectly. I mean, when we are programming, we don't type everything perfectly. We make small mistakes, and then we want the IDE to come and kind of highlight it. And those kind of things are very hard to get right, get the exact right output we want from a system like Antler. You get the line number, but that's pretty much it. Sometimes you can write kind of trying algorithms. What we will do is we try to pass it one way, and then if it fails, we try another way, and then kind of try to recover. So that will give us a good error, but all of that becomes very complex, right? So the other approach we have done is since then is this massive effort led by one of our former team members, Supun, to handwrite the parser. I also worked on the transformation bit of that, and where we write we write recursive descent style parser. So the difficult bit with this is, I mean, either way, difficult bit is kind of getting the grammar and then kind of left refactoring it. So factoring is such that it's easy to write the grammar. So not only writing the parser, the hard bit of writing the parser might not be the actual writing part, but doing the correct kind of factoring. Right. So there's a little bit of experience about writing the parsers. So we are at this side now, and the current parser works very well, and we're getting good errors, and it has, it doesn't have a lot of edge cases and bugs. So we are very happy with this approach. Right. Next choice is how to do internal IR. I mean, that's kind of redundant. I should have said just IR because IR means intermediate representation. So as I said, programming languages, usually what happens is you get a big language and then you compile it down to a smaller language, and this smaller language, we have a choice. We have to design that as another language, right? So it's the Ballerina is the big language that everyone sees, but inside the compiler there's another language that happens, right? So in our compiler we call it BIR, but if you look at other programming languages these days, they also usually have an internal IR, right? Swift has CIL, and then Rust has MIR, and then I think they have another one. So on and so on. Everyone these days have another internal intermediate language. This is other than the final IR. So final IR is also another IR these days. So we have multiple options to pick from. So what we have gone so far is this middle one, which is the register-based approach. Register-based approach is kind of the natural one. So that's what you would normally think if you are not familiar with IRs, because it's just like a programming language. You have, except when we have A and B, now A and B are replaced with this %1 and %2. But other than that, you'd see it's like a normal programming language where these are like kind of sometimes called 3 address codes, but there's some terminology, but doesn't need to be 3 address. But the rough idea is you treat these as variables, and and some systems you have a certain amount of them, and under some languages you have infinite amount of them. That's what we are doing. We have infinite number of these variables we can introduce. So it's very much like a normal programming language. So what's different is either SSA or stack machine. Stack machine is only kind of used predominantly in Jvm. It's not very popular format. It has kind of fallen out of favor, but it kind of produces a very small, not necessarily very small, but a smaller code, because what you're doing is you think of it as a stack, or writing things down on a paper, right? You ask the compiler, okay, first write down this, then write down 20, now add the 2 things, right? So it's like more like describing it to kind of a person with kind of a pen and paper, and then you at the end, because you're always using kind of the previous result, you don't have to say each instruction becomes much smaller. But this is a little bit slightly harder to produce, and then it's not that valuable, because in modern day and age, the CPUs are not stack based. So it used to be the case that some CPUs are stack based, and it's no longer the case. All the modern CPUs are register based, and anyway the lower level system is going to translate from stack based. But if we wanted to produce a code that's similar to what JVM produces, we should have used the stack machine approach, but we are not using it for even because JVM, Java JVM is capable of doing stack based as well as registers, right? So it has a stack. So again, the stack here doesn't mean the call stack. So that's a bit confusing. The call stack is a separate thing. Call stack is when you call a function from another function from another function, it builds up all the variables in a stack. This is not that stack. This is a different stack where you push your variables into. So so this kind of, well, they're kind of related, but they're not the same thing, right? So because even the register based things will have a stack, so separate thing. So JVM is stack based, but we are not using that stack part of the JVM because JVM also has a register based approach. So we are using that, and that has worked out fine for us. And the other option is kind of popular these days is the SSA approach. SSA approach is slightly harder to produce again, but we certainly didn't end up. We certainly don't see it used by the even the LLVM itself for the front end. So it's a bit of a so anyway, we might have to use it in the future to do analysis as well as kind of for intermediate variables. But I'm not going whole lot into that because it's a subject on its own. It's a complex one. So what are the pros and cons? But here's kind of the rough area we picked. And it's been working fine, and even for our new compiler we tried it and it works well as far as we can say right now. All right, so I think we have a few more things. I think just this one and the next one. So the execution model is basically how we kind of get what's the end running strategy. So we very first start with this AST approach. So AST approach is basically kind of something you get almost for free when you write the front end. So it's easy to get started with the AST approach. What it means is you look at what's produced, the kind of tree that's produced at the early stage of the compiler or front end of the compiler, and then you directly walk that tree in order to get the output. So if there's a add operation, that will represent as a add, and then first number on one side and the second number on the other side, and we look at this tree structure, and then okay, there's a plus, then I had to plus two things. I'll get this value and plus it, and then get this result and go to the higher level. So it's a tree walk basically. So and at the end of the tree walk you get the result. So this is the most natural thing to do if you just have a front end, right? And but the problem with this is there's no stopping in the middle. This is kind of slightly slower, and so this is kind of a stepping stone where we started from, and then we lived for a long time with the second approach, which is the bytecode interpreter approach. So here, instead of using the JVM as the VM, we are writing our own VM. And the core of this is basically just a for loop with a switch inside. So you produce bunch of instructions, like we discussed earlier, like these kind of instructions. Could go with either style, but you usually don't want to go with SSA for this, but say you go with some style of intermediate representation, and then or a final representation, and then for each instruction you switch to some a section of a code that does that bit. So like in this example, for example, I look at, okay, I add, then I jump to the I add adding operation, and then I do the add, and then while loop will take me back to the next instruction, and so on. So we keep on working on this long list of instructions, right? So this is how a naive VM will work. So this approach worked much more reasonably than the Ast approach, and we were able to live with this for a long time until 2019. So this had the rough performance of like Python kind of level. Um, Maybe Python has gotten faster since then, but that's a separate story. Because we are kind of getting some improvements from Jvm, because we are running on Jvm. But again, the problem with this is it's very hard for Jvm to do any optimizations when we are doing this, because the problem here is Jvm depends on knowing how the program works, program flows, in order to do its optimizations. Now, when we do this, Jvm has no idea, because we are jumping all over the code, and this Jvm can't figure out the pattern we are jumping. So it makes it harder for Jvm to do any optimization, so we are not getting anything for free. So that's the reason this is not as fast as it could be, even though we are kind of doing the same thing the Jvm is doing, but we are missing out all the optimization, good optimizations Jvm can do, right? Um, okay, so the approach we are doing right now is generating the Jvm bytecode itself. So we look at our intermediate representations is basically that looks like this, and then from that we generate actual Jvm bytecodes. So the Jvm bytecode is not significantly different from our bytecode, but the advantage comes from the Jvm itself, where it has, thousands of optimizations and uh, cheating and all that, right? So that's where the advantage comes from. It's much faster. So for the future Ballerina compiler, we are doing a similar thing, but instead of Jvm, it will be Llvm. So Llvm is another open source project, and that's leveraged by a lot of new up and coming languages, like not even up and coming, kind of establishing languages. So it's initially started by Apple, and contributed as open source project. It's what's underneath Clang, or Apple's C compiler, and then also Rust, and then all those, and a lot of new up and coming programming languages. And advantage of this is, again, despite of the first of all, despite of the name VM, it's not a VM, so it's actually a machine code generator. Uh, so the name is a bit misleading. So this machine code generator will not only generate machine code for us, we don't have to worry about producing machine code for ARM versus x86, because it's all abstracted away. So it's very nice, and they do a lot of optimizations themselves. But we have to do a little bit to cater to the style of optimizations Llvm can do, because Llvm can't. If you just generate bytecode um, in Ballerina semantics, it's not going to do very well. But if we design it slightly such that Llvm can do a good job, it can do a lot of huge amount of optimizations. We get a lot of free optimizations out of Llvm, and then we get machine code. So that's the other project we are working on. The similar way, Jvm does a lot of optimizations for the current branch, which is the Swan Lake branch. So another up and coming thing we see in the programming language space is WebAssembly. Everyone is going to assembly. Some people have already been there, but I think in up and coming years, maybe in next couple of years, we'll see a kind of rapid expansion of WebAssembly as a target language. So we do have plans for that. So, but that's long away. But yeah, that's if you like to learn, I think it'll do very well for you to, if you're new graduates, to learn WebAssembly, because that's going to be kind of a where web is going, or maybe edge computing is going in the future. So that's something to look out for. Okay. Finally, this is how the compiler is internally organized. And since we are running out of time, I'm not going too deep into this. So our compiler is layered, multiple layers. So the in our Swan Lake version has maybe I think 8, 9 kind of layers where we analyze and we desugar in multiple phases, and then this is kind of a balance. You have to struck complexity versus how many people are working on the project, and versus how much effort you put into a particular layer to make it as simple as possible. So a lot of things go in there, but I'm not going to go too deep into this because we are almost over an hour. All right, so let me end it here. So last couple of years I've been involved in this Ballerina project, and as a whole Ballerina team, this has been an incredible experience building a compiler. And now we have WSO2 Choreo plus a lot of other these connectors and whole ecosystem built on top of the compiler. So it's not just the compiler, there's layers on top of the compiler, like the way we have a rich standard library where you can work with files, where you can work with other protocols like gRPC, and we have GraphQL, which is another way of communicating. So all of these layers on top of, and even more kind of platform on top of it with Choreo. So it's a huge ecosystem, and we have we're growing, and we have it has been a incredible experience getting to hear from the beginning, and and we will continue to develop these platforms. So the the idea is to have the Swan Lake be improved, so this whole ecosystem can gather critical mass. And I hope all of you will give us a try. Couple of things you can do, very easy things you can do to help us is just to go to Ballerina website, GitHub page, Ballerina platform/Ballerina Lang, and then just give us a star. That'll be great. And but beyond that, uh, register to our Ballerina community page, where you can get more talks, more information about Ballerina. Plus, this is a good time for you to, if you try out a little bit of a Ballerina program and you write something that's useful for others, just contribute it back to Ballerina Central. Since the language is getting started, just getting adopted, if you create something small that's useful for everyone, there's a chance that it'll get very popular, and then everyone's using it, and then you can make a name for yourself if you write a little bit of Ballerina program. So I welcome you to do all of that. So that's it with, I think, the prepared part of the talk. So if you guys have any questions, if you go, I'm happy to answer them.
Thank you so much, Aya. I understand that it's a busy, I guess, weekday evening as well. So for that talk, and I think it was very valuable as well to kind of dip our toes into this sort of sphere of things. But yeah, guys, if you guys have any questions, please use whatever you're watching this video on, be it Facebook, YouTube, or Twitch. Feel free to use the comment section and just like drop a text. And I'm sure Manranga here is more than happy to answer some of them for you. I think we've got some viewers as well, different platforms.
Yeah, I understand this is kind of a whole other world, so it's hard to ask useful questions, but I certainly encourage everyone to give it a try. It's not the the compiler construction is certainly complex, but trying out the language is not. So everyone can just write a small thing, and give us feedback. Even just feedback is very useful for us. Like
Yeah.
with the Slack channel, you can join the Slack channel. Um, So the users, the Slack channel is listed in Ballerina your community page. Join to the Slack channel. There's active chat going on there, so you can experience being in Ballerina team even without joining the team. You can get idea okay how these people are working. So it's give all those things a try.
Mm, I think we'll give it a minute to see if they have any questions.
Right? Um,
Looks like we aren't really getting any questions, but I'm sure there's possibly ways to contact you afterwards, Aya,
yeah,
if they
yeah,
have any
sure.
questions. Yeah.
So the best place to contact me and the Ballerina team in general is the Slack. Okay. So
Hmm.
because if you raise any questions there, not just me, I'm also keeping an eye. Other people from Ballerina team will answer you. So uh, give Ballerina a try. If you come across any questions, clarifications, you can certainly ask them.
Right. Thanks, Aya. Again, on
Yeah,
behalf of the Street First community, we are very thankful for you to take your time off your busy schedule and just like give us this talk. Because again, these are certain topics and aspects that we don't really get to use within our university lives, but we are kind of expected to kind of know, have like a vague idea of whenever we kind of enter the industry. So I think thank you so much for kind of bridging that gap and again taking time off your schedule to kind of teach a bunch of teenagers, for the lack of a better term, these sort of things. But yeah, again, so much, so thankful, and so on behalf of the sports community, and yeah, again, thank you so much, Aya, for joining us with us today, and also for the viewers, again, like Manranga mentioned earlier, you can join the Slack channel if you have any questions regarding it, or you want to contribute or give any feedback, stuff like that. And yeah, so I think that's about it. I can probably wrap up the event as well. So yeah, thank you everyone for joining on, and thank you so much again, Manranga, for this event as well. Wouldn't have been a success without you. So yeah, good night for everyone. Thank you so
see
much.
you. Bye.
See you. Bye.
Talk to you soon.